Hi all, I am T. Shakti, Assistant Professor of Department of Information Technology, Hindustan College of Engineering and Technology. Welcome you all for a session on list. In this session, we are going to learn what a list is, what are all the various types of implementation that are possible for a list data structure, what are all the basic operation and how it has been implemented, followed by the various types of list. List data structure. A list is an ordered set consisting of varying number of elements in which insertion and deletion can be made at any position. Arrangement of deck of cards in a game can be called as an example of a list. The general form of a list can be a set of elements starting from 1 to n. Here A1 represents the first element and AN represents the last element and N represents the size of the list. The below diagram gives you how a list will look like. Getting into the types or the ways of implementation of list. List can be implemented as array-based implementation or linked-based implementation. In array-based implementation, array is being used where it is static, and linked-based implementation, self-referential structure is being used where we'll be able to add and delete element whenever there is a need. Array implementation of a list. Let us look at the array implementation of list that has been given here. Totally, we have 7 elements which is being allocated A, B, C, D, E, F and G starting from the index position 0 to 6. So, even if the memory or the array is being dynamically allocated, we have to specify the maximum size of the list that is being required. So, for example, if 100 memory bytes has been allocated and if I am making use of only 10 memory bytes, the remaining 90 will be wasted. Or if I have used only 10 bytes, that is if I have allocated only 10 memory locations and if I am in need of 11th element to be inserted, I will not be able to do it if array based implementation is used. This is the great problem of making use of array implementation of list. We will not be able to grow or shrink the size of the array. This makes us to move to the linked implementation as well. Inserting a new element at the front is potentially expensive because before existing elements need to be shifted to make room to the new element. Deleting an element is also a very big problem when we make use of array implementation of list. But find and printing the list operations can be done in a very constant time. Now let us see the common operations that can be performed in an array implementation of list. The operations are creation, insertion, deletion, display and search. Creation is making use of an array to create a fixed size of the memory, that is fixed size of the list. Insertion refers to adding an element at any location or at any position of the list. Deletion refers to removing or deleting an element from any position of the list, and display refers to displaying the content of the list or printing the content of the list, and search refers to finding a particular element from the given list. Now let us see how these basic operations are being performed in array implementation of list. Getting into the creation of the list, in this example, an array of size 10 is being allocated. So we have the index position from 0 to 9. So we have an initial empty list with 10 memory locations. Next is insertion operation. For doing the insertion operation, we have to specify in which particular position we have to insert, because in list we can do the insertion operation at any position. In the given example, we have the elements 10, 20, 30 and 40. So this is a picture which depicts you some elements which has been inserted into the list. Now let us see how an insertion is being performed in between in array implementation of list. In our previous example, we have the elements 10, 20, 30 and 40. But here we are trying to insert an element 25 in the location that is at the position 3. So if that is the case, what has to be done is that we have to shift the elements to a position ahead so that I'll be able to insert the element 25 in this particular position. So this is a very great problem if we do an insertion at the starting position. So all the elements has to be shifted a position back so that we can find a room or find a place for the new element that can be inserted. Getting into deletion. Here deletion is also having the same problem. For example, if we want to delete the element at the location 2, what has to be done is that we have to remove the element in the sense we have to shift the elements a step forward so that we can get a deleted array list. So in the given example 10, 20, we need to delete the third position, which is the memory location 2, followed by 30 and 40. After deleting the element which has been at the location 2, we have to shift the elements 30 and 40 a step forward. If we have only few elements, then no problem. What will happen if we have 100 elements after that? So we have to shift all the 100 elements a step forward. So this becomes a greater problem for both insertion and deletion of elements in an array implementation of list. For insertion, we have to move a step ahead of all the elements, and in deletion we have to move forward all the elements of the list. Linked list. Linked list can be defined as a collection of self-referential structure ordered by their logical links. Here in linked list, each node will be represented in terms of a data and next pointer. Data refers to the data element and next refers to the pointer which is going to point to the next node in the list. Advantages of linked list. Linked lists are dynamic in nature because we will be able to grow or shrink the size of your linked list. And efficient memory utilization is done as we will be able to allocate as well as deallocate memory whenever there is a need, and insertion and deletion can be performed in a very easier manner. Getting into the disadvantage, we need more memory space as we are in need to store a pointer pointing to the next field, and access to an arbitrary data item is little difficult and also time consuming. Types of linked list. There are three types of linked list: singly linked list, doubly linked list and circular linked list. Based upon the pointers that it has, these three can be differentiated. Operations that can be performed in the linked list are insertion, deletion, find next, find previous, print list is empty and is lost. As linked list contains a pointer to the next field, we will be able to do few additional operations like find next and find previous. Singly linked list. Singly linked list is a linear linked list which consists of a data and a pointer to the next node in the list. It just contains a single pointer called next which will point to the next node in the list. Let us understand how the singly linked list is being created and how the basic operations are being performed with the help of a diagrammatic representation. Let us assume that the list is initially empty. We are trying to insert an element called 30 into the empty list. So if this is the case, a new node has to be created and the element 30 has to be placed in the data field, and then we have to make the next to be null, and we have to make a pointer like list which will point to the first node of your list. In this, let us see how an element is inserted at the front of the list. So our old list contains an element called 30. We want to insert an element 20. So the newly created node contains a data element 12. And then the new node of next has to be made to point to list. And after that, the list pointer has to move to the new node so that the new node, that is the list, starts from the new node. So the elements in the list are 12 followed by 30. Inserting 42 after 12. That is, we are trying to do an insertion in the middle of the list. So for doing that, we have to do the find operation. We have to perform a find operation. That is, we are in need to search where the 12 is. So make use of a temporary pointer to traverse to the list and find the particular data item after which the insertion has to be done. If that node has been found, make it as temporary, and then we have a newly created node, new node with the data value which has to be inserted. So in this example, it is 42. So the new node of next has to be made to point to temp of next, and then temp of next has to be made to point to new node. If we do these two changes, then our current node will be, that is the current list will be 12 followed by 42 and then 30. Performing an insertion at the end of the list. To do this, traverse till the end of the list. The end of the list can be found by making use of a temporary variable pointing from the first node to the last node. The last node can be identified if the current node's next is going to be null. So traverse till the end, and after finding the last element, make the new node of next to be null and then temp of next to be new node, such that the newly inserted node will become the last node and the current elements becomes 12, 42, 30 and 54. Let us see another insertion at the end of the list. The element 60 can be inserted at the end of the list by traversing the list towards the end. And after that, we have to make the new node of next to be null and temp of next is equal to new node. So totally we have 5 elements, 12, 42, 30, 54 followed by 60. Now let us see how the deletion operation has been performed. As like insertion, deletion can also occur in the front or in the middle or at the end of the list. So let us see the first example, deletion of 12. So this is a case where we are going to delete the first node of a list. Whatever the deletion operation it might be, first we have to find the node position. So for that we have to traverse the node by making use of a temp pointer. So for checking whether this is the front node, we can check whether the temp is equal to list. If temp is equal to list, the process is very simple. What we are going to do is that we have to make the list to point to the list of next, and then we can simply delete the temporary. So the node 12 will be deleted and we will be having the current list starting from 42. Now let us try to delete the element 30 which is in the middle of the list. As already mentioned, to find the node 30, we have to traverse from the starting of the list by making use of a temporary pointer. After identifying the temporary pointer, we can check whether this is a last node or front node. If it is not, the things what has to be done is that while traversing, we have to make a previous pointer pointing to the previous node of the list. So with the help of the previous pointer, we have to make previous of next to point to the temp of next, and after that we can remove the temporary node. So the main problem in deleting the element over here is that in singly linked list is that we don't have a pointer pointing to the previous node. So manually we have to allocate a previous pointer so that deletion can be performed in a very effective manner. Deleting the last element in the given list. So this also involves traversing from the starting of the list by making use of a temporary and a previous pointer. Whenever we may move a temporary pointer, the previous pointer has to point to the previous element. So like this we have to traverse till we find the element to be deleted. After finding the element to be deleted, make previous of next to temp of next. Here the temp of next is null. So null will be assigned to previous of next and then we can remove temporary. Getting into the disadvantages of linked list. In linked list, traversal is possible in only one direction. That is, in singly linked list, traversal is possible only in one direction from the beginning of the list till the end. And if the value to be searched in a linked list is towards the end of the list, the search time would be higher in the case of a singly linked list. To overcome the disadvantages of a singly linked list, we move on with other types of linked list, which is doubly linked list followed by the circular linked list. A doubly linked list is one in which all nodes are linked together by multiple links, where it has a next pointer as well as a previous pointer. Next will point to the next node in the list and previous will point to the previous node in the list. So each node is being represented with three fields: previous pointer, data field and then next pointer. Circular linked list. A singly linked list can be made as a circular linked list by simply storing the address of the first node in the linked field of the last node. Two pointers, namely head and tail, are used to represent the first and last node of the list. A circular representation can be implemented, that is, a circular linked list can be implemented as either singly linked list as well as doubly linked list. Here is the diagrammatic representation of a singly linked circular list where we have only one pointer pointing to the next field. So this is a singly linked list where we have in the last element, that is in the last node, we have the address of the first node. As well, getting into the second representation, which is doubly linked circular list, we have two pointers previous as well as next, which points to both the previous as well as the next node. And the last node will have the address of the first element, and the first node's previous pointer will have the address of the last node. Implementing doubly linked list is a very confusing one because we are in need to have a clear idea about where the head and where the tail is. I hope through this session you might have got an insight about what a list is, how the list is being implemented in terms of array implementation as well as linked implementation, and how the basic operations are being performed, and what are all the various types of linked lists that are available. Thank you.